Today's topic is layers in the OSI model, or layers in the Open System Interconnect model. We'll discuss those different layers. We have already discussed some of the things about Open System Interconnect. So today we will go point by point at what are those layers and what are the functions of those layers. We will see one by one. As you already know that there are basically in this model, there are basically 7 layers. They are the physical layer, data link layer, network layer, transport, session, presentation, and application layers. So starting with the lowest to the highest, we will discuss what are the functions of all those layers. Now, the first layer is the physical layer, which is basically concerned about the bit streams, the transmission of bit streams over a physical medium. As you can see in this diagram from the book Data Communication and Networking by Faroujan, you can see that there is a transmission medium, and these streams of bits, zeros and ones, are being moved through this transmission medium. So the physical layer is basically concerned about how to move these bit streams in the transmission medium. So it deals with the mechanical, electrical specifications of and then in the transmission mediums, because you see that the zeros and ones represents some information. It may be text information, or it may be pictures, audios, or whatever it is. So ultimately what happens is that these streams of bit has to be converted into electrical signals. So this layer, the physical layers, deals with that mechanism of specifying what electrical signals, how these bit streams will be converted into electrical signals. So it also defines the procedure and functions that the physical device and interface have to perform for transmission. Now, let us see that you have a devices. This is one device, the sending device. This is the receiving device, and here you have the transmission medium. So this physical layer is concerned also about how this 1 and 2, which is the devices which is connected in the network, this device 1 and 2 will be interfacing, or in other words, connecting with the transmission medium. So this transmission medium can be anything, any form of transmission medium. Now, the physical layer is concerned about the physical characteristics of interfaces and medium. Okay, so this layer defines the characteristics of the interface between devices and the transmission medium, which I have just said that this is a transmission medium. It may be a wired medium, or it may be a wireless medium. How this devices that is going to transmit data between is going to communicate, or is going to connect. Who is going to interface with the transmission medium. That is what it does. And then you have also another this layer also defines representation of bits. because this layer consists of a streams of bits, zeros and ones. It's simply zeros and ones with no interpretation, in the sense that these bit streams are simply bit streams of bits which is interpreted in the higher layers. So in order to transmit these bit streams, these bits must be encoded into electrical signals, representation of bits. So whether one will be high voltage or zero will be low voltage, on all of those things. So because you cannot send zeros and ones, ultimately you have to send high voltage, high or low voltage. So since you are going to send high or low voltage, whether which number will be, I mean, which binary will be high, which one will be low. So that kind of encodification, uh, how these zeros and ones are changed into signal, is also defined in this physical layer. And then the data rate. Data rate is also taken care of in this physical layer. The data rate is the number of bits sent in each second. How fast that the data will be sent is also defined by the physical layer. So it defines, in other words, that how long will be one bit, for example. Here, if you see that one bit is this long, the next bit is this long. So, I mean, how long will it take? I mean, this signal is high for, let us say, 1 millisecond. This signal is high for a low for another millisecond. So that means 1 millisecond is one bit. So that kind of data rate is also determined, I mean, is also defined by the physical layer. Then it also is responsible for the synchronization of bits. So the sender and the receiver not only use the same bit rate, but they also must synchronize. As we have mentioned in the previous class, that when the sender and the receiver are not synchronized, for example, if A and B, A is sending it faster and B is receiving it, reading it slower, then that becomes a problem. B will become overwhelmed with streams of bits. So they, in other words, the sender and receiver's clocks, A and B, the clock of A and B devices, which is communicating in the network, should be synchronized. Then it also defines line configuration, which is the connection of devices to the media. For example, whether it is a point-to-point connection, okay, point-to-point connection, or it is a multi-point connection. Okay, this is basically what we have line configuration. So whether it is a point-to-point connection or it is a multi-point connection, that is also defined in the physical layer. Then it is also responsible for the physical topology, because topology may be a mesh topology where every device is connected to every other devices, or it may be a star topology, or it may be a ring topology, or it may be a bus topology, or it may be a hybrid topology. So what is the topology of the network? That is also specified in this physical layer. Then comes the transmission mode. The transmission mode, is here the physical layer defines the direction of the transmission between the two devices, whether it will be going from point A to point B only, or whether it will be uh, point from A to B, then after that B to A. So that kind of transmission mode. We have defined transmission mode, whether it will be simplex, half duplex, or it will be full duplex. So this also is specified in the physical layer. Now, coming to the data link layer. So the data link layer transforms the physical layer, which is simply, as you can see, a raw transmission facility. Yes, it is simply responsible. It is responsible for transmission of bits of streams in the form of signals from point A to point B. Therefore, it is a raw transmission facility. So the data link layer transform that raw transmission facility to a reliable link. What does it do? It makes the physical layer appear error-free. Chances are that when you simply transmit bits of stream, there's bound to be so much of error. So the job of the data link layer is to make that transmission error-free to the upper layers in the network. Now, what it does is that this data link layer is moving frames. Okay, if you can see this here, it is moving bits in the physical layer. It is moving bits from one hop to the next. That means from one device to the next device. It may not be. In this case, 1 and 2 may not be the sender. The original, the originator or the final destination. It may be any node in between a network. For example, these are networks, and network may go through like this. So from A, B, C, D, and E. So in this case, suppose A is sending something to E. So it has to go through these nodes. So this physical layer is concerned about moving bits, streams of bits from one hop to another. That means from point A to point B, B to C, C to D. It is only responsible for that. But the data link layer is responsible for moving frames. Okay. Now we call it frame. From streams of bits, it's become frame from one hop to another. A frame is a group of bits. So what it does is that first thing it does is framing. The data link layer divides the bits of stream. We have simply streams of bits. Those streams of bits are divided into frames so that it becomes manageable units. Otherwise, what happens is that the data, the streams of bit, if it just goes like that, it becomes unmanageable. To control error and all is not possible. So it converts that bits of stream, zeros and ones, into frames, into small frames. So it also do physical addressing. So here physical addressing means that the frames are to be distributed. If the frames are to be distributed to different system on the network, what it does is a data link layer adds a header to the frame to define what the senders or the receiver of the frame. That means which node in the network is going to be the sender and which node in the network is going to be the receiver. So that is what physical addressing is about. If you look at this from A to B, in this case, A will have an address, B will have a physical address. So A and B are having physical address. So data can move from A to B. Then from B, it can move to C also. But in this case, it is moving towards E. So the physical address, now B becomes the sender's address, then E becomes the receiver address. So that kind of hope-to-hope delivery or node-to-node, the physical addressing is done by the data link layer. Then it's also responsible for flow control. If the rate at which data is absorbed by the receiver is the rate at which the data are produced in the sender, then what happens is that if that kind of things happen, this data link layer impose a control mechanism to avoid overflowing of the streams of bits. Then it also do error control. This data link layer adds reliability to the physical layer by adding some form of detection mechanism, and then if there is a loss of frame, now it has these bits of streams, okay, are kept into small frames. I mean, now it is, suppose this is frame A, this is B, and C. For example, C has been lost. Then in transmission, then the data link layer will retransmit this frame. That means this part of the streams of bit will be retransmitted again. So that is how it controls error. Then access control. It also does access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which has control over the link at any given time. Okay, the links are the lines or the the links that connects it to the network, the devices in the network. So those has to be controlled. In some cases, in some network mechanism, in the link is controlled at what time, for example, by whom. For example, when A is sending it to B, this particular link will be controlled by A. So that kind of thing is also done. That is what we call access control. Now, what it does here is, as we can see from this thing, the end system is that between the transmission is taking place from point A to point F, okay, but it goes through some intermediate systems. In this case, it might be routers in the network, okay. Now, the data link layer sends a frames to the B, which may be a router. Then the data, and then from B sends it, from B, data link layer at B sends a new frame to the to E, and then E then sends, I mean, the data link layer again sends from E to F. That is what is the data link layer is responsible for. Then comes the network layer. The network layer is responsible for source to destination, okay? Source to destination address. That means source to destination. In this case, A is the source, F is the final destination. That is source to destination. The difference is, in the data link layer, it is responsible for sending from A to B, B to E, E to F. In this case, in the network layer, it is sending data from, I mean, responsible for sending data from A to F. So the network layer is responsible for delivery of individual packets. Now, from frame, it has become packets from the source host to the destination host. So it oversees the delivery of the packets in between the two systems in the same network. Now, if the systems are connected to the same link, there is no need for this network layer. I mean, if it is within one network, then one network, like a local area network, for example, that local area network will be connected to another local area network, and there will be another local, I mean, we have multiple local area networks which are interconnected. That means we have multiple networks. So when you have that kind of multiple connection, there is a necessity for a network layer. Otherwise, it is not necessary. Within the same network, you don't need a network layer. Because the job of the network layer is to deliver from source to deliver packets from source to destination. Now, what it does is that first thing is logical addressing. The physical addressing implemented by the data link layer handles the addressing problems locally. That means between A to B, because these two are communicating. So the address is being at this level is done by the previous layer, that is the data link layer. Now, if the packet passes the network boundary, we need addressing. That means if the packet is going outside the network, outside the network, then we need a logical addressing, because this source to destination addressing is necessary. So the network layer adds a header to the packet coming from the upper layer. Among other, includes logical address of the sender and the receiver. In this case, this network layer will add packet. Okay, I mean, we'll add data, additional streams of bit, which will include so many other things, but it would all and it would also include the address of the source and the address of the destination, so that the packet is delivered from source to destination. Then it also does routing. Now, when independent networks are linked to create inter-network, that is a network of network, a large network, which I said that you are connecting multiple networks, then a connecting device, which we call routers or switches, okay, routing or switching, okay, routers or switches, uh, these connecting devices, in this case also, as you can see, this intermediate system is a switch or a router. Okay, so these are intermediate nodes. One of the function of the network layer is to provide that this interconnection is through these intermediate systems like routing or switching is possible. Uh, that is also done by this network layer. We need the main thing is that source to destination delivery. When a network layer sends the packet to the network layer at B, when the packet arrives at B, the router makes a decision. Okay, when the packet arrives here, from here to here, the router, by consulting its routing table, that means routing table is uh, the table which contain a directory kind of thing, which contains all those devices which is connected within that network. So by consulting the routing table, it finds a next hop, which is E. Instead of C, it decides to send to E, because if it is sent through C, it will not go to F, because there is no connection here. So therefore, it will send to E, and then it ultimately will go to E. Sometimes this decision is also done at on the basis of which route will be the best way to, or the free, which route is free for delivery of the packets. Then we have the next layer, which is the transport layer, which is responsible for delivery of message from one process to another process. Now, from packet, we are coming to message. Okay, so the transport layer is a process-to-process delivery mechanism. So when we said a process, okay, process may be uh, an application program. Okay, a process is an application program which is running on the devices which is communicating. Now, a process, whereas the network layer sees that the source to destination delivery, okay, in the network layer, it is concerned about from delivery of packet from source to destination. The transport layer is concerned about delivering from one process to another process, which we say is an application program. For example, an email, okay, an email program, the program that is used to send email is a process, or some other, a browser, for example, is a process, an application program. So this uh, the in this case, the network layer, when in the network layer, A to F is communicating, but the this relationship between, I mean, what is the devices which is sending? In A, you may have multiple processes. You have email open, you have browser open. Here also, maybe email is also open, browsers are open. Okay. So it is not, in this network layer is not concerned about whether email is when email is being sent, then it should be, the receiver should be another email process, right? Not that an email is being sent, but something else is receiving it. For example, a browser, it is displayed simply in the browser, directly in the browser without the email client. So that would be wrong. So that is why we have the transport layer, which uh, delivers the message from one program to another program. So what it does is that, as you can see here, for example, here we have so many processes. Let us call them process A, B, and C. A, B, and C. For example, B is a is a browser in this case, for example. Then this process on the receiving side is also a browser. So a message is being sent through from a browser to a browser here. Okay. In this case, what happened is that this destination process that is being run from this process, it has to be delivered in the correct process, even if it has all of these three running. So that is what the transport layer is responsible for. So what it does is that the first thing is service point addressing. The computers will run several programs at the same time. At any given point of time when we are using computer, there are several programs running. So for this region, the source to destination delivery means delivery not only from one computer to the next, but also from a specific running program to another specific running program. So that is necessary. The transport layer does this. Header must therefore, the transport layer add a header which includes a type of address called service point address. Okay, service point address. Here, the header which is added by the transport layer, we have here multiple headers, which is called service point addressing or port address. The network layer gets its packet to the correct computer. The transport layer gets the entire message to the correct process on the computer, the correct program in the computer, because the header contains a service point addressing. So the other thing it does is that segmentation and reassembly. When a message is transmitted, okay, usually it is divided into transmittable segments. So each segments, I mean, for example, this is a message, bit streams. So this will be divided into small segments, 1, 2, 3, 4. So each segment is given a sequence, so that when it reads there, when it is transmitted, 2 may go first, after that 4 goes, after that 1 goes, then after that 3 is being sent. So this is how it is being transmitted. But once it arrives here, there should be a mechanism where it is again organized into its proper order, 1, 2, 3, 4. So that is also done by this transport layer, which is called segmentation and reassembly. It divides the message into different smaller segments and then reassemble them according to the correct sequence. Then it is also responsible for connection control. Now, the transport layer can be either connectionless or connection oriented. We'll be discussing about this in detail, but as of now, what you can understand is that a connectionless delivery or a connectionless A connectionless transmission would be, for example, you have multiple devices. Now, what happened is that uh, connection at the point of at the time of sending from A to B, this is being sent. Then let me put some more. Let us say C. Then it goes to C, C to B to C. Then it goes to D. It goes to E. So without the final destination, let us say E, D, E. Okay, is between A and E. Now, without establishing a connection, dedicated connection, we are relying on the connection between A and B. At that point of time, C and D may not be connected, D and E may not be connected. So we are from point to point, we are delivering the message. That is connectionless. But connection oriented is that before the transmission take place, all of these things, a circuit is being established. That means A, B, C, D up to E, a connection is established. Then only the message is being sent. But after the message is sent, this connection is broken down again. That is connection oriented. But connectionless relies on point to point. I mean, from A to B, B to C, like that. So this is decided by this transport layer, whether it should be a connectionless or connection oriented delivery. So a connection oriented layer makes a connection with a transport layer at destination first, and then okay. Now flow control. The transport layer is also responsible for flow control. Like the data link layer, this layer is also responsible for error control. Error control at this layer is between process to process. In the transport layer is between device to device, node to node, or hop to hop. But in this case, this is about process to process. It is from one application program to another application program. Now, the sending transport layer makes sure that the entire message arrives at the receiving transport layer without error. That is damage, loss, or duplication. So if there is any error, then it will be resent again. Now, this is how the transport layer makes the process, from process to process delivery, a reliable mechanism of sending messages. Okay. Then we have the session layer. This session layer is responsible for basically two things: dialogue control and synchronization. Now, the session layer, dialogue control means that the session layer allows two systems to enter into a dialogue. That is, it allows communication between two processes to take place in either in half duplex, one at a time, or in full duplex, two-way at a time modes. Or it can have a synchronization. That is how it is done. Okay, dialogue control. That is one way at a time or two way at a time. Okay, and it also does synchronization. It allows process to add checkpoints or synchronization points to a streams of data. For example, if we are sending thousands of pages at a time, then what it does, the session layer will divide these thousands into maybe 100. Okay, that way, if error occurs in the first 100, then only that part will be sent again. So that is how it does synchronization. Then coming to the presentation layer, which is responsible for three things: translation, compression, encryption. So this is about the syntax and semantics of information exchange between the two systems. Now, the transport layer, first thing is the translation. The process, that is the running program, in two systems are usually exchanging information in the form of characters. strings, right, or numbers, and so on. Now, the information must be changed into bit streams. All of these things should be changed into zeros and ones, right? It has to be changed into zeros and ones. Now, because different computers are using this changing of characters, strings, numbers into zeros and ones, we do what? Encoding, which we have discussed in the previous class. So encoding is done. But what happened is that different systems use different encoding mechanism. There is a possibility of two devices having different encoding, following different encoding methods. So the presentation layer at the sender change the information from its, the at the sender, it changed the characters, the strings, and the numbers that we are going to send into a coding system which is used by the sender. And then what it does is that the presentation layer then converts into a common format, okay? A common format. And at the receiving machines, in a common format so that it can be transmitted. But once it comes to the receiving devices, machine, what it does is it converts back into the encoding standard which is used by the receiving mechanism. That is what translation is about. Then it also does encryption. Sometimes we send sensitive information. Today everything is sensitive information. This encryption is very important. So the system must be able to ensure that there is some privacy. That encryption means the sender transforms the original information to some other forms and sends the message to the network. And then at the receiving end, that encrypted message is being decrypted again for the sake of privacy. Then we have the compression. Some data needs reduction. For example, files like audio, video, it needs to be the streams of bit which is used to represent the audio, video, or images. It tends to become very big, very large. So in order to transmit, it needs to be compressed so that transmission is faster. So accordingly, this compression is also done by the presentation layer. So if it does a compression, decompression also is done. Then is the application, coming to application layer. Now this layer is responsible for service to the users. Okay, this is important. It enables the user. So when we say user, user may be not necessarily a human only. It may be human, or it may be software. Okay, whether the user is human or software, this layer is responsible for giving service to that users, so that the human or the software users can have access to the network. So it provides what? How does it allow? How does it serve the users? It serves the users by providing interface, okay, and support user support services such as email, remote access, remote file access and transfer, shared database management, and other types of services. Now, if you look at these diagram, a user, which may be a human or a program, is using this particular thing, is trying to send some files or using these services. Okay, using these services to transfer files between between this. So it goes from, this is the top, so there is no other layer. So it goes to the lower layer, to the presentation layer, and ultimately it will come back to the from the presentation layer. It will go, and then what it does is that this particular interface is being shown. For example, there is a file transfer between these two, then there will be an interface where these two are transferring files, okay, using this particular user interface. So user interface, there can be multiple user interface. Now what this layer does is, first thing is network virtual terminal, which is a software version of a physical terminal. It allows user to log in. Okay, for example, when you are using accessing some network, you can log in to that network site remotely. That means you are logging to the server. So to do so, the application creates an software emulation of a terminal at the remote host, and the user computer talks to the software terminal, in which turn talks to the host, and so on. So communicating with one of its own terminal. Okay, so virtual terminal is created in this, made possible in this application layer. Then the next thing is a file transfer access and management. This application allows a user to access file remotely, to make changes or read data. For example, you have a computer here and computer here, and then you log into A, and then you can access B as if you are locally accessing, controlling B. Then it also provides mail services application, the basis of forwarding and storing of mail. It also allows directory services, this which is basically used for distributed database sources, and access for global information about various other services. So these are some of the things that is done in the application layer. Now, in summary, if we look at the summary of these different layers, the top layer, that is application layer, which is closest to the user, allow access to network resources by providing user interface. Then we have the presentation layer, which is basically concerned about translation between communicating devices, encryption, and then compression of data. Then we have the session layer, which is basically concerned about establishing a session, managing the session, or terminating the session. Then, the session layer. Okay. Then we have a transport layer. It provides reliable process-to-process, software-to-software, or program-to-program message delivery. And then it also is concerned about error recovery between process to process. Then we have the network layer, which moves packets from the source to the final source, and to the source and the destination. And this also allows internetworking. That means having a network established across multiple networks. Then we have the data link layer, which organizes bits into frames, and then it provides hope-to-hope delivery from one hop, or from one node to another node in the network. And then we have the physical layer. It transmits bits over a medium to provide, and then it provides mechanical and electrical specification to really convert bit streams, binaries, into electrical signals. So this is the summary of the different layers of OSI model, Open System Interconnect model. So with this, we have come to the end of today's class. Thank you.